Good afternoon. This example is a significance test, one-sided significance test for a t-distribution, and it is for problem 10.71. I've adapted it a little bit in your textbook. The data is from page 682, and basically what we're looking at is a bill from 50 customers, randomly selected customers, to see if in fact we are paying on average more than $20 a month for service. So to start the process, the first P in phantom for a hypothesis test is parameter. So mu is going to equal the true mean monthly cost of internet service. All right, the next part of a hypothesis test is setting up the hypotheses. Our null hypothesis is that we in fact are paying approximately $20 a month. Our alternative is that people are paying more. So the key factor right here is this number. That number is going to be at the center of our normal curve eventually. Now we must test the assumptions. First assumption, X bar is from an SRS as stated above. So mu sub X bar, which is the mean of our sampling distribution, which I call master X bar, is an unbiased estimator of the population parameter mu, which we stated up in our P is the true mean monthly cost of internet service. The next assumption is that we have approximately normal distribution, and we're not told anything about the population. So I have n equal to 50, which means I can absorb quite a bit of skew, but I must check for outliers. So I need to, in my calculator, have loaded in list cost, is what I called mine. And I am now going to plot this data in a histogram. And I am calling it cost. I'm going to superimpose a box plot over top of this so I can look at them at the same time. And that again is list cost. And let's now take a look at this, Zoom 9. Well, it appears that I have quite a few outliers if I trace my data. So this is not a good situation. However, we are going to continue. So I am going to trace this on to my plot. And I'm going to say it appears that the sample contains many outliers. This will affect the sampling distribution. Proceed with caution. Technically, we should not be moving on since we have all these outliers, but we are going to continue. So I'm going to have to unsafely assume that the sampling distribution is approximately normally distributed. All right, so that is really a big concern. We have a major fail there. Finally, n equals 50, and 50 times 10 is 500, and I think it is safe to assume that that is less than the entire customers and the total customer population. So the standard error is S divided by the square root of n for the sampling distribution that we technically don't know if it's normal or not, but we continue. Okay, that is the hardest and longest part. Now I'm going to name my test. I'm going to do a t-test for a population mean with 49 degrees of freedom. Doing a t-test because we are in the real world and we don't technically know what our mean or our standard deviation of our population. Now we have to obtain the test statistic, find the test statistic, and obtain the p-value. So remembering up above that my mean is sampled at 20, I'm going to draw a normal curve with 20 in the center, and I don't exactly know what the standard deviation is. So I'm going to do one variable statistics on my list cost. So I'll quit out of here, stat, calculate one variable statistics on my list cost. And I need that data over here. And that lets me know that my sampling or my sample has a standard deviation of 7.645. So I'm going to use 7.65 as my S sub x bar. And now I have to calculate the standard error of SE sub x bar, which is the sampling distribution standard deviation, 7.65 divided by the square root of 50. So if I want to be really accurate about this, I'm going to use variable statistic, and I'm going to use number 3, which I'm hoping that, yes, that is the right number. So I'm going to use that divided by the square root of 50. And I get 1.0812. So I'm going to use 1.08 as my standard error. So now I can draw my graph. 20 goes in the middle. And I'm going out by 1.08. So I have 21.08, 23.16, I believe, would be my next value. And then the last value, adding on 1.08, I think that's 22.16. 22.16, and then if I add on 1.08 there, it's going to be 23.24. I don't technically need to do the other side. I can do my 0, 1, 2, 3 for my normal curves, or for my standard deviation, or standard curve deviation. All right. Well, my X bar is 20.9, so that's going to come down in here. So already I'm feeling like perhaps they are telling the truth. And I want to find all of this area. What is the chance that I would get something as high as $20.90, given that the real answer is 20? Well, now I have to calculate the test statistic finally. And to calculate the test statistic, I have 20.09, that's the sample mean, minus the population mean of 20, divided by the standard error, which is 1.08. So I am going to get basically 0.9 divided by 1.08, which is 0.83 repeating. That is my test statistic. All right, now I have to obtain the p-value, but first let me write my notation. What is the probability I could get as an X bar as high as $20.90 or higher, that's greater than, which is approximately a t with 49 degrees of freedom of 0.83 or higher? That's what I'm looking for. This answer will help me make my decision. So, bringing up our calculator again, I'm going to choose the program Draw T. I'm going to do it as a t-score right now, so I have 0.83 repeating. And my upper bound, I'm going to pick something big. Let's just put in 100. The degrees of freedom are 49. The mean is 0, and the standard deviation is 1. And hopefully that gives me a picture very similar to what I drew already. And it tells me there is a 20.43% chance. So that looks pretty similar to what I have up above. My answer that I was looking for was 0.2044. Well, let's just verify that by doing stat. Oops, press enter to clear my screen. Stat tests. I want to do a t-test. I have data. My mu is 20. I want to use cost. And frequency 1, I want to do greater than 20, and I'm going to do a draw, which will verify my t-test statistic and my p-value, I'm hoping. And there it is, 0.8323. And this I just want us using to check our answers right now. So this is Draw T results over here, our program, and this is the stat T test default in our calculator, and it verifies our answer. So now the last point is to make a decision. This is extremely weak evidence against the null hypothesis. Okay, so let's say what the evidence is. A p-value of 0.2044 means that this observation, which is our sample that we just took of the 50 and had a mean of 20.9, that this observation or this sample would occur approximately 20 out of 100 times by chance, by random chance alone. It is not statistically significant at alpha equal 0.05, and that's because, and this is important or the AP people take off a lot of points, 20.2044 is less than, or I should say is not greater than, I'll just do less than 0.05. All right, therefore, what do I do? Let's try that again. Therefore, I do not, notice it is not statistically significant, so I do not reject the null hypothesis that the true mean monthly cost of internet service is $20. So maybe I'm one of those people that had quite a large bill this last time and I'm thinking that they're lying about their monthly service charge. Well, I can now say, guess it's just me. Maybe it's my kids texting too much, something like that. But I cannot go back to the company and complain.